In this next video, we are going to look at some of the laws of logarithms that we're going to use to simplify longer expressions, so not like the ones we talked about before, but also to start solving equations. So some of these properties are a little different than the ones we looked at before, and these properties go back to some of the ones that we saw for exponentials. Okay? So for logs of logarithms, we need to start with some conditions. First, we're going to let little a be a real number such that a is greater than 0 and not equal to 1. And so notice these are the same conditions we had for all of our exponentials and all of our logarithms that had a base of a. We also want real numbers a, b, and c, where a and b are greater than 0. C can be any real number, positive, negative, or even 0. But for a and b, these need to be strictly positive expressions. Okay? So if we look at our properties, the first one says that if log base a of a times b is given, then this is equivalent to separating these into a sum. In other words, if I have a product of arguments, then for a logarithm, I can separate it into a sum of logarithms with the same base. Okay? Similarly, for a division of arguments, so if I have an a over b inside of a logarithm, I can separate it into a subtraction of logarithms. So a log base a of a minus a log base a of b. Now this is the property I alluded to back in a previous video, where I said we talked about if the base of the argument and the exponential, or the logarithm, were the same, we could use the fact that it was a function in its inverse. Here we're kind of expanding that. So if I have a logarithm of any base that has an argument that is exponential, I can bring the exponent of that argument out to the front of my logarithm and think of it as a multiplication. Now you do have to be a little careful with this property because a lot of times people will confuse this with a power of a logarithm, and that is very different. Here that power has to be on the argument. And if I were going to make this kind of even more clear, I would say we are looking at when their parentheses are this way. So it's truly inside the logarithm. Okay. Those are the three main ones that we'll use quite a bit. The last property here is one that is useful for some of your other disciplines. So for example, in chemistry and in physics, a lot of times you're going to be using logarithms of other bases. And in order to calculate things or to simplify nicely, we want to be able to put it into terms of bases that are useful to us, like the natural log or the common log. So this last one is what we call the change of base property. And it basically does exactly what it says. Given a logarithm of a particular base, doesn't matter what the argument or that base is, I can change it to any base I want by taking the log of the new base of the argument divided by the log of the new base of the old base. And here you have to be a little careful not to confuse this with property 2. This does not become a difference of logarithms, because I am looking at the division of logarithms, not the division of arguments. Okay? So here, this is really useful for us because usually we're going to let a equal 10 or a will equal e. Now, like I said, it works for any base. So, like I said, in other disciplines we may need to choose something different. But for our purposes, to actually evaluate the numbers and get some nice decimal approximations, we're going to use these two bases. Okay, so let's look at some examples where these properties are used. And here I just have some logarithmic examples or expressions that we want to simplify using these properties. Okay? And one of the things to keep in mind for these is it is not always going to be put in these forms so that you can just look at them and say, oh, I'm using this property. Oftentimes you're going to have to rewrite or manipulate the expression so that you can get it into these forms and use these properties. Okay? So if I look at this first one, log base 3 of the square root of 27, Well, here, this is one where I'm going to have to do a little bit of rewriting. Okay? As it stands, it doesn't match any of my properties. But I can think square root of 27, we can think of as 27 to the 1/2 power. So using our exponential properties. And then taking that a step further, I can think of 27 as 3 cubed. So it's going to be 3 to the 3/2 power. And so this is where that property we talked about before, combined with our property 3 here, says that I can simplify this down. So the 3/2 power will come down to the front. I'm going to multiply this by log 3 of 3, which if you remember is just 1. Okay. So in this case, our log 3 of 27 is just going to be 3/2. Okay. In this one, actually let's go to this one next. So here, log base 12 of 9 plus log base 12 of 16. In this case, if you notice, as they stand, neither one of these can be simplified, right? 9, there's no nice way to write this as 12 to a power, and 16, there's no nice way to write that as 12 to a power. So here, it doesn't quite look like it, but this is what I'm going to use that first property on. Because if I combine those, I'm looking at log base 12 of 9 times 16, which is log base 12 of 144. And that we can rewrite using that third property. This is just log base 12 of 12 squared. And so doing the same thing we just did over here, we can see this is 2 times the log base 12 of 12, which is just going to equal 2. Okay, so without that addition or multiplication property, we wouldn't be able to simplify that down nicely. Okay. These last two examples are going back to a combination of the base and argument property that we had in a previous video, but it also looks at, well, I've got multiple logs in my problem now. Okay. For these, you're always going to work from the inside out. So don't try to start with the outer logarithm. Try to start with the inner things. Okay? So the first thing I notice inside these parentheses here is my base on my logarithm isn't written. So remember, that just means I'm looking at a common log, which is base 10. So here, that log base 10 of 10 to a power, well, that's just what we looked at right here. So that's 10,000 times log of 10. Well, log of 10, because it's a base 10, is just going to be 1. So we're just looking at log of 10,000. And then we can do the same thing. Well, to get that base 10, I can rewrite this as an exponential. This is 10 to the 4th power. And so again, the base, even though it's not written there, that's 10 to base 10 of 10 to the 4th, which again we can bring down as 4 times log of 10. And again, that log of 10 is just 1. So this one is just going to be 4. Okay. This one's not too bad because it has the same base all the way through. Sometimes you are not going to have the same base all the way through. The idea is the same. I'm going to start from the inside and work the way out. In this case, we're looking at natural logs inside of there. Natural log of e, well, that's the function and its inverse. So those are going to cancel out. So just like before, that's just 1. So now I'm looking at log base 3 of 243. Well, again, not quite the same base, but I can rewrite the 243. Okay. Again, for these, you're definitely going to need to know your multiplication tables. Okay, so here I know that 243 is 3 to the 5th. And so again, I can use my power property. I can bring that down And then from before, again, log base 3 of 3 is just 1. So the last law that we had on our list was the change of base property. And again, mostly what we'll be using that for is to find decimal approximations of particular logarithms. This is not used to actually solve equations or to solve expressions like we did before, but mostly it's going to be used to, given a logarithmic expression, find a numerical value for it. Okay? And so this is only going to be used in our purposes for when we are looking at applications and we want to find that value at the end of the application. Okay? So here are two examples of this. The first, so both of them we want to evaluate to 4 decimal places. And so the first one we're looking at is just log base 3 of 5. And again, the reason we need this change of base property is because right now, if we tried to put this into a calculator, almost no calculator will do this directly. Okay? There's no log base 5 button or no log base 3 button on most calculators. You will see the common log or the natural log. And so that's why I said in our change of base property, we're usually going to want to pick base E or base 10. Okay? For this first one, I'm going to pick base E. And again, it doesn't matter which one you pick as long as you're consistent with the problem. So here, using our change of base property, it says I'm going to look at the natural log of the argument over the natural log of the base. Okay? And so now I can actually put this into a calculator. And again, remember, you have to enter it directly, meaning I need the natural log of 5 divided by natural log of 3. So you're going to have to put parentheses in there where needed. You can't just put ln of 5 over 3 because you're going to get a different answer than what you're looking for. Okay? So here, if I plug in and round this to 4 decimal places, we see this is about 1.464, and then it becomes 97, so we're going to change this to 50. Okay, so there would be our log base 3 of 5 rounded to 4 decimal places. Okay. For the other logarithm, let me come over here. For the other logarithm, this one now I have some coefficient out front. So I'm still doing the same thing, but I want to add a little bit more to it. So it's not just the logarithm I'm evaluating. Here I'm still going to use my change of base property. And for this one, I'm going to use our common log. The 8 that's out front just gets carried along. So here I can think of this as log base 12, log of 12 over log of 5, and then I'm just going to multiply by 8 out front. And if you like, you can think 8 log of 12 over log of 5, and it doesn't matter which way you write that, you'll get the same thing. Okay, from there, we're going to go ahead and plug into the calculator. Again, I need logs on both of those. Okay, so when we plug into the calculator, we get about 351. It'll come out to be 658 or something like that. So we'll round up to the 4 decimal places. So there would be our approximation. Okay. Now again, when you are doing your assignments, this means your homework and your web assign, this is the last step. So you've done all of your work, you've simplified down, and then you're going to want to plug in. You need to read the problems carefully, because some of your problems, it will say to leave it in terms of a particular logarithm. In some cases, you're going to be asked to leave it in terms of a particular logarithm and give the decimal approximation. So it'll tell you which base you're looking for in those instances. Okay. On an exam, obviously you're not going to be allowed to use calculators, so you're going to leave your answers in simplified forms based on the logarithm it asks for. So if it says to solve using base 3, for example, I would leave my answer here. If I'm asked to solve and leave it in terms of natural logs, I would leave my answer here. Okay? So you have to read these problems carefully to see what form you're going to be leaving your problems in, or your answers in. And again, for the applications on the homework and the web assign, you're going to want to take these down, and again, make sure you round to the correct number of decimal places.